What's up, Algebra 2 students? Mr. Messner here. Uh, Last kind of section of notes and homework. It's like day 3. Put this behind me, mostly to block the people who are walking around here. But also, I think the theme of Unit 1 for a lot of us should be don't be afraid to start over. Don't be afraid. Which way do I need to go that way? Don't be afraid to do things like you've done them for the first time here. Don't be afraid to do it a little bit differently than you've done it before. We're trying to relearn things so that we have a better understanding of things versus this is how I've done it, but you don't really know what's going on. Okay. Some things that I differ from other teachers is I'm okay with variables being on either side. I told you in the past videos, you don't have to have, x equals 5. You could have x equals 5 on the other side. I don't know where my cursor is. There it is. You don't have to have x equals 5 like that. You could have x equals 5 like this. You just read it from right to left. And I think that's very important when we get to this lesson is that it's okay to end up with your variables on the right side. They don't have to be on the left side. Don't do the same thing all the time because depending on the situation, it might be advantageous to do it somewhere else. Okay. Now, the difference between this set of questions that we're about to do and the questions that we finished off part 1 on, which were questions where we had variables on the same side. Like I had, where am I? Right here, negative 3x minus 6x. On this side, on these questions, we had variables where it's the same side, we can combine them. Okay. I owe 3x's, I owe 6x's, I owe 9x's on this side. I have negative 9x's on this side. Okay. We don't do what we're about to do for that question. Like this question, same side combined. For these questions that we're about to do, our variables are on both sides of the wall. Okay. It's not same side combined. My computer's reading. I actually need to plug this in. I'm not sure if this video is going to come out very well because it's not plugged in. So that means my computer moves slower than normal. Sorry if this is boring you. There we go. We have princesses over here, princesses over there that we need to save. Okay. What we need to do is combine them. Okay. And I'm going to do it one step at a time. Now it's not same side combined. Instead, it's undo things or move by adding the opposite. If you add the opposite, these k's are gone from this side of the equation. And now they're over here. Even though I tell my students they're not doing it, I hate subtraction. Change it to add the opposite. It'll help. Now, after doing this, we have a multi-step equation that we worked on, where it's undo what's being done to the variable, 3 is being multiplied, then the 2 is being added, the negative 2 is being added. So undo that. Get rid of the 2 first by adding 2 to both sides of the equation. Keep the balance. And then get rid of the 3, undoing multiplication division. Now you're going to learn this, and then we're going to go back to these problems, like on your quiz and on your test, and you're going to think to froze again. You're going to think to do that same thing. I'm warning you. You're going to think to do this. Oh, subtract 2x, subtract 2x. You can't. You're unbalancing things. You are taking away 4 x's from this side of the equation. The equation will break. Okay, you will no longer be in balance. You're going to, be unbalanced one way or the other. So you don't do this. Same side combined. Opposite sides eliminate. Okay. But really, it's just one more step to what we've been doing. Now, let's go to this one over here on the right. If you wanted to, you could make sure your x's always ended up on the left side. Your variables always. I don't like having negative numbers or negative variables if I don't have to have them. Okay? If I wanted to, and you need to be okay with this, you could move your variables to the right side of the equation. So many students are not comfortable with this, but you should be because it's cool. Math is great, universal, left to right, right to left. Who cares? As long as you understand, like, okay, here's my variable on this side of my equation. What's being done? 4 is being multiplied, 4 is being added. I'll add the opposite. I have -4 plus -4, I get -8. And then I divide by 4. Now, many of you will not do that. And I'll just show you how we're going to end up with the same answer. It's just going to come about in a different way. Here, look, my answer. X is -2. Okay, that's the missing value. You guys like to get everything on the left side. It's going to work. Just like it's okay to not do it. You guys will then add 4, and then you'll divide by -4. And you get the same answer. It's not that bad. Just whatever you want to do. Don't be afraid of doing either way. Here, I'm going to remove these x's from this side. It's not same side combined. It's like remove from one side so they remain on the other side. Pop them over the fence, But it's not pop them over the fence. It's like remove them so that they only remain on one side. Fractions. What's more, 2/3 or 1/2? I wish I had more where like there's more on the right side. 2/3 is more, 1/2 is less. I like to always end up with a positive, so I'm going to subtract the half from the 2/3. The only way I can subtract, which is add the opposite, is to have a common denominator. I need the same type of pizza slice. This is 4/6, smaller pizza slices. This is 3/6. Combine them. I have 4/6. I owe 3/6. I now have 1/6. Some teachers teach you to do like 2 steps at once. Move the variables onto one side, move the numbers onto the other. I don't like to do that. I prefer doing it just variables first and then solve the equations we're used to solving. Look, if you're messy, you might think this is a -5. Like I actually used to be messier than this. I know it's shocking, but I've learned that like you got to keep track of. You have to be neat and orderly. Make sure your x's look like x's and not y's. Make sure you don't throw some things and all of a sudden you think you have a negative. How do you get rid of the 1/6? Well, you could divide by 1/6, but then you have to do 9 divided by 1/6. You're going to have to flip the bottom. Sure, some people probably are doing this still. Flip that and multiply. Or you can multiply by the reciprocal. Dividing by 1/6 is actually the same as multiplying by 6. Fifty 54. Same thing here, but it's easier to combine because I don't need to multiply both of them. 5/6 minus 2/3 times 2 times 2. I got 5/6 minus 4/6, which is 1/6. Another 1, 6. Look at that. Plus a negative 1 equals 11. Same side combine, opposite sides eliminate so they remain. You can't combine them, you'd break the rules. Same side combine, opposite sides eliminate. Ooh, look at Mr. Messner with the next example that he put together. Get rid of 1, 6, divide by 6, same as multiplying by 12. Don't have a calculator? Don't be scared. All right. This is the practice of like both of the things. Same side combine. Oh, I have 4 plus I have 1x. I owe 6 x's. I'm in debt 5 x's. You can't add the 4. I have 1 apple. I owe 6 apples. I owe 5 apples. I have 4 oranges. Here, I have 8 oranges. I owe 4 apples. I owe 2 oranges. I have 8. I owe 2. I have 6. I net 6. This was just step 1, same side combine. Step 2, variables on 2 sides. Eliminate so that they remain. Now, watch what I'm going to do. I noticed something. Negative 4, negative 5. I could either add 4 x's to both sides, or I could add 5 x's to both sides. Adding 4 x's would eliminate these, and it would combine with these. But then I'd be left with a negative 1x. I don't want to do that extra step of dividing by negative 1. I'm going to choose to add 5 x's to both sides. I choose this because I now have just x, 1x. And now, with one step, where's your variable? What's bothering it? The 6's, not the 4. With one step. I get that. Okay? Same thing here. I could subtract 8r's or add negative 8r's, but then I have a negative. I don't want negatives. So maybe maybe this is something new. Don't be afraid to start over and do something new. Let me write that something. Okay. Hold it away. All right. Now, which side? We're over here. R. Multiply by 6, added 10. Undo it. Get rid of the 10. Don't worry about that 4. That 4 is not bothering anybody. Get rid of the 6. Undo it. Divide. Okay. I'm going to turn those into negatives so I don't make mistakes. Add 2/3 to this side. Why? Because 2/3 plus negative 1/3 will be 1/3. Positives. I like positives. I like to think positively. Here's my variable on this side of the wall. Eliminate the foes. Undo what's being done. Divide by 1/3? Sure, you wanna divide by 1/3? Fine. I don't want to. It's the same as multiplying by 3. Notice, these are techniques. It doesn't involve that much thinking, which is great. Because imagine trying to, guess and check this with numbers, it'd be exhausting. Techniques help us. Step-by-step processes help us. We're thinking like a computer. Hey, computer, if you ever see this, do this, then this, then this, and this, and you will solve. Okay? Here, I will eliminate the three X's so that they remain on this side. Make sure you pay attention to the wall. Same side combined, opposite sides, undo. Now I just have one X, add two, hip hip. Hooray. Okay. There are a lot of times where you'll have to distribute values so that you can combine variables and numbers. Yeah, sure. Like this 1/2 we talked about last notes. It's like you could get rid of that like first because it's what's happening last. But the problem is like if I decide to divide by 1/2, that actually would work. I could multiply both sides 2 to start if I wanted to. It'd actually be nicer. Maybe I'll do both. But most of you are used to like distributing. I have like half of a bag of y plus 6. Well, I have half of a y and I have half of 6. So I have 3 plus a half y. Now, actually, let me give you some space there because I'm going to show you another way to do it. Over here, I'm going to actually multiply by 2 because it's like the last thing that's happening over here. So like I'm not going to break any rules if I multiply by 2. You don't multiply everything by 2, and that's why this is confusing, which is why like maybe don't do this, guys. It can be done, but a lot of people then think distribute, but it's like 1/2 times something times 2. When you're multiplying, you can multiply anything in any order. Yeah, just multiply that first. Don't distribute. Anyways, I'm going to remove the 1/2 y so that they remain over here. 3 over 1, multiply the top and bottom by 2, turns into 6 over 2. Subtract a 1 over 2, you get 5 over 2. Y. Look, my y's and x's. And over here I have 3. Oh, this is a great example. Sorry. A great example of where students make mistakes. Let's maybe do this one over here. If you want to put variables on one side, and you always like to put your variables on this left side, watch what happens, and a lot of students make mistakes. So pay attention here. I know some people are just going through the motions if you're watching this video, but pay attention. Watch what happens if I subtract 6y here. You're like, okay, y plus negative 6y, that's 1 minus 6, or 1. I have 1, I owe 6, I'm netting down 5. You have the 5y, and then you have the 6. Here's what a lot of students do. They're like, I guess they equal each other. Pay attention, guys. Wrong. This is why sometimes it's not beneficial to put all of the variables on one side. Because a lot of students don't realize that on this side of the wall, after you've gotten rid of the 6y's, you have nothing left. A lot of people, when we solve equations, we don't write these zeros. When you add 2, you don't write x plus 0 equals 6, right? You just eliminate it. You eliminate it because it's plus 0. And you're like, the 0 is not going to do anything. You're like, why would I put this? Because it's just this, right? And that's why many students make this mistake of you eliminate the 6y and then you don't put this 0 down, even though it's necessary. What you have to now do is subtract 6 and then divide by negative 5. I'm going to hopefully see more of these. I think I put more of these in here because I know you guys make that mistake. And it's like, yo, heads up. Let's not make that mistake. I'll show you if we do it here. If you like to put your variables always on one side, be careful. there's no numbers left on this side, you got to put a 0. You have to put a 0. Uh, 3 over 1 becomes 6 over 2. Negative 6 over 2 plus 1 over 2 is negative 5 over 2. And now you have to isolate the y. What's happening? Multiplied by negative 5 halves, add by 3. I'm going to add the opposite. And then multiply by the reciprocal. Multiply straight across. Fractions are easy to work with like that. Double negatives, positive. I'm not a good teacher. All right, challenging you here. Yo, get rid of these subtraction symbols, please. Two sides of the wall. On this side, I owe 5 apples. I have 2 apples. A net down 3. Same side combined. On this side, well, I don't know what I have yet because I owe 2 bags of this. It's like, oof, don't worry about it. Instead, just like distribute so that we realize, okay, I owe 2. Okay, this is important. This is a negative 1b. Negative 2 times negative 1b is positive 2b. Like so many subtractions, so many negative symbols can really screw us up. Be careful. Add the opposite. I saw my students yesterday being comfortable with changing this to that. But I did not see many students feel like they should do that. And that's okay. I mean, just wall, same side combined. Yo, you want to put the b's over there? You're going to have negative b's. I'd rather have positive b's. So I'm going to choose to add 3b to eliminate the b's from this side so that they remain here. Don't be afraid of trying something new. Oh, look at Mr. Mister. After all that, b's here. What do? Eliminate the 4, adding the opposite. And my solution for b is 0, and that's okay. 0 divided by 5 is 0. All right. Could divide by 2. It's like, don't do that. That's going to be weird. It's really like distribution will always be there to help you. So let's do that. Oh, great. 3 times 2 thirds. 6 thirds, which is 2. Or you can see like the 3's cancel and you're left with 2. So I have 2 q's plus negative 12 over here. 2 times a half. Oh, that's easy. 2 over 1 times 1 over 2. 2 over 2. That's just 1. 1 q. And then a 2. Hey, I have 5 oranges. I owe 12 oranges. Same side combined. If you didn't, it'd be okay. Like say you move the q's onto that left side. So you move the q's over there. You could then like subtract the 5 and add the 12 in 2 different steps. It's okay if you don't like do things like the exact way I do it. We just got to end up at the right answer, you know? So don't be afraid of doing something new. Doing something new might even be, and I'll show you, not same side combining. Here, this is me doing something new. How many q's is this? 1. 1. Watch. Ready? What's happening to the q? 5 is being added to it, 12 is being subtracted. Get rid of the 5. Both sides of the wall, both sides of the equation. Keep things balanced. What happens? Now you have q plus negative 12 equals negative 3. because I added negative 5. Now add the 12. I have 12, I owe 3, a net 9. Okay, look, I did something new. I didn't same side combine, but I'm still going to get the right answer. Now, that's just showing you guys multiple things to do. Just don't break the rules in whatever you do. Instead of doing that, you'll see it might be quicker to same side combine, just like I told you. I have 5, I owe 12, I net down 7. Okay, pay attention to the wall. Where is your variables? All right, more distribution. Just be careful. Let's put a 1 here. Add the opposite here. Let's distribute. Let's distribute. Pay attention to negatives. Add the opposite. Same side combine. Here's my wall. Well, I got 5 oranges. I owe 3, netting 2. I owe 1. I owe 6. I owe 7. Do you want to deal with negative or positives? I like positives. Here's my variable right there. What's bothering me? 3 is being multiplied, then the 7 is going to be added, the negative 7. Undo it. Reverse order of operations. T equals 3. Read from right to left. That's fine. Cool. Now, let's see what happens here. Get rid of some of these subtractions. Understand where our wall is, where the pivot point of our balancing act is, and same side, combine some stuff. I have 1 apple, I owe 6, net, I owe 5. I have 6 oranges, I owe 2 oranges, net, I'm going to have 4. Wait, hold on a second. Negative 5x plus 4. 4 plus negative 5x. Heck, I guess I could even have written this differently. Negative 5x plus 4. Same thing on both sides. What happens if I add 5x? Well, this is 0 x's. I put that 0 there just in case. What happens if I get rid of the 4's? Well, that's 0. 0 equals 0? What does that mean? All right, whatever. We'll go to the next one. Same side, combine. Wait, hold on. 6 equals negative 17? What? Yo, fam. When we solve equations with variables on both sides, we have the possibility of there being no solutions or there being any number possible, infinite amount of solutions. Now, I don't want to say infinite solutions. It's like, let's not say solutions of no answer or like any answer. There's other situations with infinite solutions. So just going to say any answer. Okay? Why this is important is like, let's go back to this. Plug in 1. 1 plus 4 minus 6. 1 plus 4 minus 6, that's 5. 5 minus 6 is negative 1. Okay. 6 minus 5 minus 2. 6 minus 5 is 1 minus 2 is negative 1. If x could be negative, x could be 1. I just found that x could be 1. This is me just like guessing and checking using my brain. Let's plug in 2. 2 plus 4 minus 12. 2 plus 4 is 6. 6 minus 12 is negative 6. 6 minus 10 minus 2. 6 minus 10 is negative 4 minus 2 is negative 6. Oh, okay. I guess x could be 1 or 2. Again, this is me just figuring it out. Well, let's try 0. 0 plus 4 minus 0 equals 6 minus 0 minus 2. 4 equals 4. Oh, 0 could be a solution. Oh, guys, guess what we're going to find? Because you have negative 5x's plus 4, and you have negative 5x's plus 4 after you combine, you realize like x could be anything. Now, when we say anything, we mean like any number. And to say any number, we like to say like any number that's real. We don't like to work on imaginaries. We'll get to imaginaries later. Any real number, like any decimal that you could possibly think of. Big numbers, small numbers, negative numbers, positive numbers, doesn't matter. However, over here, let's look at this after we same side combined. 6 plus a number equals negative 17 plus the same number. Think about this. If I take a number and add 6, will I ever get the same thing if I take that same number and add negative 17? No, they're going to be going in opposite directions. My number, I'm going to make it bigger. My number, I'm going to make it smaller. It'll never work. And how we know if it's going to be anything or nothing? Well, you either can end up with a true statement after your variables are gone. 0 equals 0 or 4 equals 4. Like 4 equals 4. True. Yes, 4 will always equal 4. The variables won't affect things. True, no x's, anything. You end up with a false statement. Does 6 equal negative 17? No. That means like there's no solution to have things are balanced. Turns out this is balanced no matter what. And this is actually not an equation. Like that equal sign, that's false. Like, yo, you made a mistake. You set up your balance incorrectly. You can't solve it. It literally started out unbalanced, and there's no way to balance it. Okay? So what we're going to do here is typically same side combine, realize how much we have on each side, and then figure out, are we going to end up with a true or a false statement? I notice I have 7 times our x's on both sides. I notice I also have over here negative 4. Same exact thing. If you wanted to like go through the process of eliminating things, you realize, oh, negative 4 equals negative 4. You realize like there isn't one specific number that will balance it, that will make sure it's balanced. Any number will keep it balanced. X can be anything. I'm totally cool if you guys just write anything on your test or quiz for me. Other teachers might say any number that's real, like any decimal. That's like the symbol for anything in math. Anything not imaginary, which we'll get to. All right. Boom. 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 Put a 1 there. Wall. Same side. Come on. Have 8, I owe 9, I net negative 1. I have 2, I owe 15, I net negative 13. Add 1x to both sides, or notice it's like, oh, same amount of x's, but like I'm adding this, but I'm subtracting this. Like it's just unbalanced. This is unbalanced to begin with. This is not balanced. This is not true. No matter what, the equation is broken. This is not a correct statement that this equals this. No, can't be. Can't happen. Illegal. Okay? This is a good one. Careful. If you eliminated the 6y's, since you're on this side of the equation, you gotta signify that you have 0 left over there. I didn't have enough other examples of like you had 0 left over on one side. Those would be good practice problems to do. Not true, not balanced, can't ever work, not an equation. No solution for y. Well, same side combined. Ooh, perfectly balanced. No matter what, turns out like the 2 times the x is not going to make any difference to it because it's just always balanced. This is always balanced no matter what number x can be. X can be anything, and it'll work. I'm going to do just a couple of these extra practice problems because I'm going to go to your homework. I want to pick these two especially. Okay? Because let's pretend you like to put stuff on the left side always. If the sub is watching this video, pause right here and have them try this. Okay? And then like play, see if they got it right. If y'all don't like doing things that are new, if y'all always put the variables on left side because you're American and you like to read things from left to right, y'all might not put a 0 here. And you'd get 9b equals 99 just because you're like, well, the equal sign needs to go somewhere. No, don't put it anywhere. It goes right there where it belongs. You might not realize that the solution is not 11, but negative 11. Same for this one. If you like to put your variables on one side always, guess what? You might forget to put a 0 there. Don't. For both examples, even though there'd be negatives over here, I'd probably move the variables onto the side where it's just variables. For both examples, I probably would like go 99 equals negative 9b in the first step rather than having to do multiple steps. In this example, I'd probably subtract the 2/3 of an x so that it's on the right side. So I'm going to do that. I'm going to show you that. Add a negative 2/3 of an x, add a negative 2/3 of an x, 3/3 x minus 2/3 x, 1/3 x, multiply by 3, multiply by 3. This eliminates having to have a 0 on one side so that you then have to do multi-steps. Just having variables on one side helps. Now, other teachers in the past might have taught you like get your variables on one side, get your numbers on one side in the first step. I don't like doing that. I don't like doing that, especially when the same side combining kind of comes into play. It might like make it faster, but too many mistakes made. Let's keep it slow. Don't be afraid to start over and try something new. Okay. If it just helps you always get the right answer. I'm telling you, like at this level, great job for showing your work. Sure. But like, we got to get the right answer, guys. Like, we're getting closer to like the real world. In the real world, like, you put something together, a presentation, like, you're working with actual money, you can't make mistakes. So you got to just make sure you get the right answer. Great, you showed your work. In the real world, showing works means nothing, okay? Unless like you have work done, you then go check it with somebody, and it's like, oh, I can see where you made your mistake. That's fine, but man, what if you don't check it with somebody? What if you don't check it yourself? You just made like a crucial mistake, uh, and all of a sudden you're fired. All right, homework video coming up.